Welcome to our YouTube tutorial on the law of conservation of momentum. In this video, we'll explore one of the fundamental principles in physics that governs the motion of objects. Understanding momentum and its conservation is essential for comprehending various real-world scenarios involving collisions and interactions between objects. By the end of this tutorial, you'll have a clear understanding of the law and its applications. So, let's dive right in. We'll start by understanding the concept of momentum. Momentum is a vector quantity that depends on an object's mass and velocity. Simply put, it measures the tendency of an object to keep moving in its current direction. We'll delve into the equation for momentum and clarify its units and significance. We'll learn how to calculate momentum using the formula P equals to m multiply v, where P represents momentum, m is the mass of the object, and v is its velocity. We'll work through several examples to demonstrate the calculation process effectively. Let's do some numerical on momentum. What will be the momentum of a stone having mass of 10 kilograms when it is thrown with a velocity of 2 meters per second? Mass, m, equals to 10 kilograms. Velocity, v, equals to 2 meters per second. Momentum, p, equals to unknown. We know that momentum, p, equals to mass, m, multiplied velocity, v. Therefore, P equals to 10 kilograms multiplied 2 meters per second, which is 20 kilograms meter per second. Thus the momentum of the stone equals to 20 kilograms meter per second. Let's do another numerical. The mass of a goods lorry is 4,000 kilograms and the mass of goods loaded on it is 20,000 kilograms. If the lorry is moving with a velocity of 2 meters per second, what will be its momentum? Velocity, v, equals to 2 meters per second. Mass of lorry equals to 4,000 kilograms. Mass of goods on the lorry equals to 20,000 kilograms. Therefore, total mass, m, of the lorry equals to 4,000 kilograms plus 20,000 kilograms, which is 24,000 kilograms. Momentum, p, is unknown. We know that momentum, p, equals to mass, m, multiplied velocity, v. Therefore, P equals to 24,000 kilograms multiplied 2 meters per second, which is 48,000 kilograms meter per second. Thus, momentum of the lorry is 48,000 kilograms meter per second. I hope you understood how to calculate momentum. Let's practice few numerical. Here are the problem questions for you to solve. Pause this video and solve these numerical. 1. A vehicle is running with a velocity of 5 meters per second. If the momentum of the vehicle is 5,000 kilograms meter per second, what is its mass? 2. If the momentum of a flying brick is 50 kilograms meter per second and its mass is 10 kilograms, calculate its velocity. 3. A car having mass of 1,000 kilograms is moving with a velocity of 0.5 meter per second. What will be its momentum? Here comes the core principle. We'll explain the law of conservation of momentum, which states that the sum total of momentum is constant, provided no external force acts on body. m1u1 plus m2u2 equals to m1, v1 plus m2, t2. This principle is crucial in understanding various physical phenomena. Let's derive the formula of conservation of momentum using an example. Suppose two objects A and B of masses m1 and m2, moving with initial velocities u1 and u2 in opposite direction to each other in such a way that they are going to collide. Momentum of object A before collision equals m1, u1. Momentum of object B before collision equals m2, u2. After they collide, the objects bounces back with velocities v1 and v2. Momentum of object A after collision equals m1, v1. Momentum of object B after collision equals m2, v2. On collision, the object A and B exert force F1 and F2 on each other respectively. Force exerted by object A on B equals to F1. Force exerted by object B on A equals to F2. According to second law of motion, F1 equals to m1 bracket, v1 minus u1 upon t. F2 equals to m2 bracket, v2 minus u2 upon t. According to third law of motion, F1 equals to minus F2. So, m1 bracket, v1 minus u1 upon t equals to minus m2 bracket, v2 minus u2 upon t. Time, t will be eliminated using cross multiplication method, so we are left with m1 bracket, v1 minus u1 equals to minus m2 bracket, v2 minus u2. On rearranging the equation, we get m1, u1 plus m2, v2 equals to m1, u1 plus m2, v2. Congratulations! You've now learned about the law of conservation of momentum. This essential physics principle plays a significant role in understanding the behavior of objects, in motion and interactions between them. Now, we will discover the real-world applications of the law of conservation of momentum. From car crashes and sports to space missions and fireworks, we'll explore how this principle helps engineers, scientists, and even athletes make critical decisions. Recoiling of gun on being fired. The recoiling of the gun occurs due to the conservation of momentum. Before firing, the gun and the bullet are in a state of rest. When the trigger is pulled, the bullet gains momentum in the forward direction, but to maintain the total momentum of the system at zero, as no external forces are acting on the system, the gun must acquire an equal and opposite momentum in the backward direction. Bursting of cracker. Before the cracker bursts, it is in a stationary state. When the cracker is ignited, a rapid chemical reaction occurs inside. This chemical reaction produces high-pressure gases and heated particles, resulting in an increase in energy within the cracker. As the gases and particles expand outward, they gain momentum in the direction opposite to their expansion. The acquired outward momentum causes the cracker's outer shell to rupture and break apart. The released gases and heated particles propel in various directions with high velocities. Rising of rockets in upward direction. Before a rocket launches, it is in a stationary position on the ground. When the rocket's engines are ignited, a controlled and powerful combustion process takes place. The propellant is rapidly burned, producing hot gases and high-speed exhaust that are expelled downward through the rocket's nozzle. As the hot gases and exhaust are expelled downward with high velocity, they carry momentum in the downward direction. To obey the principle of conservation of momentum, the rocket gains an equal but opposite momentum in the upward direction. This upward momentum propels the rocket off the ground and into the sky. A balloon tightly filled with air rises up when it is punctured from below. Before the balloon is punctured, the system consists of the balloon filled with air at rest. The air inside the balloon has a certain momentum, which is zero as its velocity is zero, stationary. The momentum of the system, balloon plus air, is also zero, as there is no external force acting on it. When the bottom of the balloon is punctured, the air inside starts to escape. As the air escapes, it is expelled downward, and each escaping air molecule gains a downward momentum. As the escaping air gains downward momentum, an equal and opposite momentum is imparted to the rest of the system, the balloon, and the remaining air inside it. The balloon air system now acquires an upward momentum. The acquired upward momentum causes the balloon to move upward. Let's do some numerical practice of conservation of momentum. A railway wagon of mass ton moving with a velocity of 10 km/h is hit by another wagon of mass 1.5 ton moving with 15 km/h such that they move together. Calculate the final velocity of wagons. M1 equals to 0.5 ton, which equals to 0.5, multiplied by 1000, means 500 kg. M2 equals to 1.5 ton, which equals to 1.5, multiplied by 1000, means 1500 kg. U1 equals to 10 km/h, U2 equals to 15 km/h. We1 and We2 equals to We. Putting values into the formula, M1, We1 plus M2, We2 equals to M1, U1 plus M2, U2. 1500 multiply We plus 500, multiply We equals to 1500, multiply 15 plus 500 multiply 10. Taking common We, bracket 1500 plus 500 bracket close We equals to 22,500 plus 5,000. We equals to 27,500 upon 2,000. We1 equals to 13.75 km/h. A missile gun of mass 1.5 ton fires a shell of mass 15 kg with a velocity of 150 m/s. Calculate the velocity of the recoil of the gun. M1 equals to 1.5 ton, which is 1.5, multiply by 1000 which means 1500 kg. M2 equals to 15 kg. We2 equals to 150 m/s. We1 equals to unknown. Putting values into the formula, M1, We1 plus M2, We2 equals to M1, U1 plus M2, U2. 1500 multiply We1 plus 15, multiply 150 equals 1500, multiply 0 plus 15 multiply by 0. 1500 multiply we1 equals to minus 15 multiply 150. we1 equals to minus 15 multiply 150 upon 1500. we1 equals to 1.5 meter per second. Now it's your turn to practice some numerical on conservation of momentum. Pause this video and solve the numerical. I will share answers in my next video. If you have any questions or need further clarification, leave a comment below, and I'll be happy to assist you. Don't forget to like this video, subscribe to our channel for more physics tutorials, and hit the notification bell to stay updated with our latest content. Thanks for watching, and see you in the next video.